A really great question in the lecture, and I did answer that question in the lecture as well. But I believe it also requires another 3 minutes of emphasis in this video as well. And the question was, would it make any difference? Would it make any difference if I were to bring the existential quantifier from here and place it right after the universal quantifier? Meaning that, can I do this? Can I do can I do this? Okay, so at a first glance, it seems that, well, it doesn't make any difference. It still means one of the same thing, and things seem okay, and maybe that should be fine. But let's try to spend a little bit more time on this, and let's think about that. You know, what are the implications of doing this? So if I see the statement in orange, what it tells me is that for all x's, there exists some y. Okay, so let's think about this. If I have a universe of x here, a universe of big X, and a universe of Y, okay? What this tells me is that if you were to select some X, let's select X1 here. The moment I select some X, there is some Y. There is some Y in this domain of red here, okay? So there could be some Y1 over here, okay? If I select some other x, if I say, all right, let me select some x2 here, because I'm going across every single x, I'm going across every single x. If I select x2 over here, there exists again some y, which could be y1 or it could be some other y, right? Because there does exist some y out there for x2. But what this tells you is that this is going to be true for every single x. For every single x, there does exist some y. Okay, that's what this statement in orange is implying. But what I really want to say in this question is that a multiplicative inverse of a real number x is a real number y, and this y does exist only for certain x's, such that the x has to be not zero. Here's the key: the x has to be not zero. So for all x's, I'm going to go in this orange domain. For all x's, as long as you can give me those x's such that x is not equal to 0. Keep in mind that in this statement over here in red so far, I haven't even talked about y. I haven't even mentioned y. All I'm saying here is so far. So let me put it this way. I'm just saying that if you can give me an x such that x is not equal to 0, and once that becomes true, once this hypothesis, once this red box, the hypothesis, this is my hypothesis. Once the hypothesis is true, then this arrow telling is the then thing. Then there exists a y. So if the hypothesis is true, then yes, there is some y out there, such that xy equals to 1 is going to be true as well. Okay, but if the hypothesis becomes false, if the hypothesis is false, and the hypothesis will be false when you have x being 0. So 0 not equal to 0 is false, and when the hypothesis is false, well, then it doesn't matter. It doesn't matter what the conclusion is, right? The conclusion in this case is going to be false as well, because there's no such y that exists. But that doesn't matter, because for the conditional statement, this entire piece is also going to be true, right? When the hypothesis is false, doesn't matter what the conclusion is. Everything in green is still going to be true. So this box in green is going to be true. Is going to be true for all x's.